So today we are walking through a mixed review of our laws of exponents, and we have a special guest with us who's helping us along today, and we have Jeter. So Jeter's going to be with you today, helping you along with exponents. So some great advice coming from Jeter. So on each slide, I am going to pause this video. I do want you to try the problem on your own first, and then I'll work it out together and you can see if we got the same answer. Great advice, Jeter. I'm so glad that you joined us today. So here's the first problem. Try it on your own. So on this problem, you should have said that you're using the zero exponent, the law of zero exponent. Remember, anything raised to that zero power is 1. So here we have everything inside the brackets. The answer is 1. Try this one. Did you use product of power rule? If you did, you're correct. Here our bases are the same. Okay, so product of power rule says that if our bases are the same, we are simply going to be adding our exponents. So here I have a 4 plus 2. Nothing left with that b negative 5. So I have a to the 6th, b negative 5. Can you leave that answer like that? Nope. On this one, we're using 2 laws of exponents. So now we need to use our negative exponent rule. Okay. Remember, negative exponents are a no-no in math. So we are just simply going to flip the location. I am not touching my a to the 6th because it's positive. It is going to stay in the numerator. And instead, I'm going to take my b to the negative 5, and I'm going to put that into the denominator, making that exponent positive. Try this one on your own. So you should have used quotient rule because we are dividing. So remember, with quotient rule, if the bases are the same, we are simply subtracting our exponent. So here I have the same base of my a. So this is a, 5 minus 3. And then I can do the same thing with my b, 6 minus 7. So I'm left with a to the 2nd, b to the negative 1. And as you saw on the previous slide, we cannot leave that negative exponent. So we've got to use our negative exponent law. Okay, so we leave our a to the 2nd on top over b. Do you need to write that 1 in the exponent field next to the b? Nope. So leave it as it is, and that is your answer. Try this one. So here we are going to use our law of product of powers. Okay, so same thing, bases, add the exponent. Same bases, add the exponent. So I have x to the power of 3. And what is this x here? What power is it raised to? You're correct if you told me 1. So I have x, 3 plus 1. And now I have the same with 4, same base, add these exponents, y, 4 plus 2, and simply simplify. So I have x to the 4th power, y to the 6th power. Looking at all of my exponents, they're all positive. There's nothing further to simplify. This is my final answer. So on this problem here, we are going to use our power to a power rule. Okay, so we have our negative a to the 2nd power, and everything inside these parentheses is raised to the 4th power. So our power to a power rule says that we are going to multiply these exponents. So I have that negative a, and it's at 2 times 4. Okay, just multiply these exponents, and I'm left with negative a to the 8th power. On this equation, we are using our negative exponent rule. I have c raised to the negative 2, okay? So remember, negative exponents are a no-no in math. So I'm going to leave d to the 4th in my numerator, and I'm going to change the position of my c. I'm going to send that down to my denominator, making that exponent 2. There is nothing further to simplify. That's it. Try this next problem. And I like Jeter just gave you a good reminder. Remember, coefficients do not follow the same rules as exponents. Nothing has changed on how you're going to work these coefficients. So what power did you start off by using first? I hope you said the product of power rule. Same bases, okay? Add those exponents together. Remember, this is an exponent of 1, exponent of 1, so I have my x 1 plus 1. Then I can do the same thing with my bases of y 1 plus 3. So let me simplify my exponents first. I have x to the 2nd power, y to the 4th power. And as Jeter has reminded you over here, great reminder, Jeter, we now have to simplify our coefficients. Coefficients do not follow the same rules as exponents. What would you normally do with these coefficients? How would you normally solve 5 times 2? Yes, just multiply it. So we're at 10x squared y to the 4th, and that should have been your final answer. Take a look at simplifying this problem. You see Jeter has popped in at that corner just to help you along. Let me know what you think. So on this problem, the law that you should have used was the power to a power exponent rule. Remember, the power to the power exponent rule says we are going to multiply these exponents. I consider it as we're just sort of distributing, just like you've done when we have solved equations. So I have x 2 times the 4th, y 3 times the 4th, and I simplify that down. So I'm left with x 2 times 4 is 8, y 3 times 4 is 12. Final answer. So go ahead and pause the video and try this one. Now, did you say negative exponent law, the law of negative exponents? You are correct, because these negative exponents are a no-no, so we're going to move them from the numerator to the denominator. So when you did that, did you move your 4? Did you move your coefficient of 4? I hope you said no, because what is the exponent that 4 is currently raised to? It is not negative 2. It is simply 1. So 4 is going to stay in our numerator spot, and we are now just moving our x negative 2. So I'm moving that from the numerator to my denominator so I can turn this into a positive exponent. And then I don't want my y to feel neglected. It has the same problem, negative exponent. I'm down to y negative 3. I'm sorry, positive 3. Nothing more to simplify there, okay? Nothing more to simplify there. So that is our final answer. Which law are you thinking of using here? Did you say the quotient rule? You're correct. Go ahead and pause the video. Try this on your own. So remember, quotient rule says that if I am dividing same bases, I'm going to subtract the exponent. So here on the numerator, I have x to the 12th power. Denominator, I have x to the 1st. So quotient rule says I am simply going to subtract those exponents. Okay, x 12 minus 1 is x to the 11th. So x is going to remain on our numerator. Now let's take a look at what's still left in our denominator. I have that 3 and I have y to the negative 4. Have I done anything different with my coefficient of 3? No. Is there anything left to simplify? Not at all. So I'm just simply going to leave my 3 in the denominator and then my y to the 4th. Nothing less. There's not a y in the numerator spot. Do not create one. Don't create extra work for yourself. We're just rewriting it, keeping it where it is in the denominator. That is our final answer. So go ahead and pause the video, try this one on your own. I see jitters popped in here on the left-hand side to give you a reminder to pay attention to where that negative sign is. That's a great reminder. So hopefully the rule, the law of exponents that you are using is our power to a power. So the first thing is here, I have this -2 on the outside of my parentheses. So power of a power says that I simply am going to take that power and multiply my exponents. Remember, 3 right now is raised to the power of 1. X is raised to the power of 1. So first step is still, I'm going to keep this in parentheses because I do not want to forget about that negative sign. So I have 3, 1 times 2, and x, 1 times 2. And let's simplify both of those. So I'm left with 3 squared, x squared, okay? Still, for my sake, I just want to leave those in the parentheses just so I can keep it straight, bringing that negative down. Do not leave your answer in this way. Still has more to simplify. What is 3 squared? You know it's not 6, 9, x squared. Now, because that negative is on the outside of the parentheses, okay? Do we square that negative? Nope, not at all. Just tack it on to the end of your answer. And that's your final answer. Is it okay that our coefficient is negative? Yes, coefficients do not follow those same rules as exponents, so do not change the location of that coefficient. It is okay for our coefficients to remain negative. Those rules do not change, but we cannot have negative exponents. So looking at this next problem, Jeter is giving some great reminders. I know initially in your gut you may have seen this and thought, oh, it's dividing, I'm going to use the quotient rule. But that's not the case. Why is that? Because our bases are not the same. We cannot subtract, okay? We can only subtract these if the bases are the same. We can only use the quotient rule if the bases are the same, okay? So on this one, it is actually the law of negative exponents. Negative on r to the 5th, s to the -1. You know negative exponents by now are no-nos. So we're just simply going to change their locations. I'm going to bring my s to the -1 to my numerator, making that positive. And remember, because it's now it's to a +1, I am not going to write that power of 1. It should always just be assumed that that is raised to the power of 1 if it's not there. And for my r to the -5, I'm going to send that down to the denominator, so I'm left with r to the 5th power. That is the final answer. So on this next one, we are going to use the power to a power rule. Okay, remember, power rule says that we are simply multiplying our exponents. If you need to remind yourself, what is that -2? Remember, this negative inside the parentheses, it is attached to this 2. Okay, they are together. What is that -2? What is the exponent it's raised to? Yes, it's 1. So I have -2, 4 times 1. Remember, multiplying our exponents is to the 4th. And x, 2 times 4. Okay, you should know that 2 times 4 is 8. So I'm raising it here to the 8th power. Now, you are not finished. Why? Because here, coefficients simplify that down. So remember, if I were to expand this, that is the same of saying -2 times -2 times -2 times -2. Okay, so -2 times -2 is +4 times -2 is -8, and -8 times -2 is +16. So -2 to the 4th power is a +16. Is there anything further we can do to simplify our x to the 8th power? Nope, not at all. That is as low and simplified as it can go. So this is our final answer. Go ahead and pause the video and try this one on your own. So hopefully you stated that the law of exponents that you're going to use is the law of negative exponents. I know once again you're probably thinking quotient rule, but do I have another b on the numerator's position? No, so there is nothing that I can go ahead and subtract from. So here I have a b that's raised to the -3 power. You're always already aware that negative exponents are a no-no in math. So I'm going to take my b to the -3rd power and switch that to my numerator. Now, I know you're thinking, well, what about that 2? Okay. What is the coefficient 2? What power is it raised to? It's not -3. It's a power of 1. Power of 1, positive exponent, do not touch the 2. Leave it where it is. So I'm at 1/2. Okay. And since I flipped my b to make that positive, b to the 3rd. Now, I do not need to put that 1 in front of my exponent b. So I'm simply going to leave this as b to the 3rd over 2. And that is my final answer. Go ahead and pause this video and try this one. In this problem, we are going to use quotient rule. I have same bases of a. So quotient rule says if my bases are the same and I'm dividing, I am simply going to subtract my exponent. So I have a 3 minus 3. So we know that this is a to the 0. Okay. Now, our zero exponent rule says that any non-zero number raised to a 0 power is 1. So I'm left with 1 on the numerator. And then what about my poor b that's still on the denominator? Just move it over to the denominator. That's it. So let's pause the video, try this one on your own. There are going to be 2 laws of exponents that you're going to be using here. Hopefully that was a hint for you. Okay, so the first law of exponent that you should have used is the power to a power rule. Remember here, power to a power rule. Here are the parentheses. I have x to the 2nd power raised to the 3rd power. So power to a power rule says I'm going to multiply these. Okay, so here this simplifies to x to the 6th. And I just bring these down, so that's a multiplication, and x to the 4th. Okay, now I am using product to the power rule. It says if it has the same bases like it does here, I have a base of x, I am adding my exponent. So I have x 6 plus the 4th, and that simplifies to x to the 10th. Final answer. So I hope you enjoyed this mixed review practice on exponents. I'm so glad that Jeter was able to join you, help you along. I agree with Jeter. Great job. You are an amazing mathematician. If you struggled with anything, work these problems again or refer to some of my previous videos on these law of exponents. And remember, just like Jeter has, subscribed to Mrs. Gray Math.